Thank you. Thank you, Camilla, for this introduction. And as Camilla already introduced, we are, the three of us, we are applied researchers. And so we are applied researchers with interest in causal inference methods. We all learned about causal inference methods about 7 to 8 years ago. And we did recognize the importance of these methods to improve our own research and to apply these methods within our applied research domains. So I want to highlight that we're definitely no experts in causal inference. We learned about it and we recognize the importance for our own research, and we now want to apply these methods in our own research domain. But we're definitely no experts, as many of you will be. So since we were convinced about their importance and the need to apply them within our research domain, we tried to spread the word about causal inference methods to our colleagues and other applied researchers in our research domain. And we did this by talking about causal inference to our immediate colleagues, but we also gave some workshops about causal inference methods and in particular DAGs, for example, at the annual meeting of the International Society of Behavioral Nutrition and Physical Activity. We included causal inference methods in courses for our master level students in health promotion and public health. And at Ghent University, we organized a symposium with national and international speakers about the potential of causal inference within psychology and health sciences. And lastly, we also wrote some papers, for example, this commentary paper about the importance of causal reasoning within the domain of behavioral nutrition and physical activity. Despite the fact that we got some positive reactions and that people were interested in applying these methods, we noted that after they had attended the workshop or after we have talked about these methods with them, that they just continued work as usual and they did not really apply the causal inference methods in their own work. So apparently there are some barriers preventing people to apply causal inference methods in their applied health research. And from a previous study by Bernard Myers, we know that knowledge is one such barrier. So in this qualitative study, we examined the barriers towards using DAGs in applied health research, and they observed that many of the respondents who did not use causal graphs reported a lack of knowledge as a barrier to using DAGs in their own research. We also noticed this importance of knowledge when we organized the symposium on causal inference in psychology and health sciences at Ghent University. We had several international and national speakers who actually did a great job in explaining causal inference methods to an applied audience. But afterwards, we heard from participants that it was still quite hard to grasp everything. For example, one participant mentioned it was interesting, but for someone who just started their PhD, it was very difficult to follow. I'm kind of overwhelmed. So maybe that's me, or maybe I was just not the target group of this symposium. So knowledge seems to be an issue, and I think there is an important knowledge gap between applied health researchers and causal inference experts. So if the goal is to increase the use of causal inference methods in applied health research, one important barrier to overcome is that we should increase applied health researchers' knowledge about causal inference methods. And one solution that we consider a potential option is to include causal inference methods early on in methodology and statistics courses at university. But we know that explicit causal reasoning and causal inference methods are only rarely introduced in basic methodology and statistics courses. So apparently there are also some barriers for lecturers to include these causal inference methods in the introductory methodology and statistics course. So the aim of this presentation today is that we want to discuss the barriers that are experienced by lecturers to integrate causal inference methods in methodology and statistics courses, and to present some solutions to overcome these barriers. So what we do is that we treat the integration of causal inference methods by lecturers as a behavior change. And this is actually an area where we do have expertise, or we should have expertise at least, since we have a background in health promotion and health psychology. And we developed a study, in fact, or an approach to apply our health promotion theories to the behavior of the integration of causal inference methods in methodology and statistics courses. And the ultimate aim is, of course, to present some strategies to promote the integration of causal inference methods in academic curricula and ultimately in applied health research. So how did we do this? We did not come up with the barriers and solutions ourselves, but we discussed the barriers and potential solutions during a special interest meeting here in Ghent last year. During this meeting, we invited causal inference experts, applied researchers in psychology and health, but also teachers and consultants in statistics to discuss about their experiences with teaching causal inference methods and the potential barriers that teachers might experience. Now I give the word to my colleague Annick, who will present what we specifically today.
Yes, so as Jelle explained, we are dealing with a behavior change problem, and within the field of health promotion, several behavior change theories exist. And one of the most encompassing models is the CAUSALab model. So CAUSALab stands for capability, motivation, opportunity, and behavior. So the model posits that if you can change capability, opportunity, and motivation, then this will elicit the behavior. And so under capability, we understand the psychological and physical capacity to engage in the behavior. So basically the knowledge and skills. Under motivation, we understand the processes that energize and direct behavior. And this can be both reflective processes, such as goals and decision-making. So these are things that you do consciously. They require some effort. And on the other hand, we have some automated processes, such as habits and routines that we have. So these just happen automatically. And then the last one is the opportunity. So these are factors that lie outside the individual that make the behavior possible or prompted. And there we have both the physical opportunities. So these are more things in the physical environment. And then you have the social opportunity. So these are things, the social environment, so the people around you. For example, social supports could be an example of that. And a metaphor that is sometimes used is a rider that is riding an elephant, and the elephant walks a path. And so there the rider represents the reflective motivation. So this is responsible for all the deliberate and goal-directed planning and guiding actions. While the elephant is a metaphor for the automatic motivation. So this automatic motivation prefers the easy, the well-trodden path, such as the unhealthy habits. And it also easily returns to it when it becomes difficult. For example, when you're stressed or when you're tired, then you easily return to your routines or to your habits. And then the path is a metaphor for the environment. And there, the environment, of course, may foster or may facilitate some of your behaviors and inhibit some of your other behaviors. Now, the CAUSALab model is at the core of actually a larger model, which is called the behavior change wheel. And this larger model not only shows us the barriers, I just explained, so the capability, the opportunity, motivation, this is what we want to change. It also directs us with some solutions. It also gives us some solutions, which is called the intervention function. So these are strategies that are aimed at addressing these barriers. So these are here indicated in red. And then we also have policy categories. So these are policy measures to facilitate the intervention functions. And these are indicated here in gray. And so policy can only influence behavior through the interventions that enable or support the behavior. Now I give the words to Louise, who will explain the barriers.
Okay, so now that we have some background on the COM-B model and the behavior change wheel, let's look at the behavioral diagnosis. So the behavioral diagnosis provides an overview of the capability, motivation, and opportunity factors that need to be considered in order to alter the behavior. So for capability, we have psychological capability. And during the discussions, we found that sometimes lecturers themselves have limits or have a lack of knowledge on formal causal reasoning. And they also have limited experience with using causal inference methods, which of course acts as a barrier to introduce these methods into their courses. And we also found that the same is true for example, master thesis supervisors. For example, Jelle and I, we taught causal inference methods in our course for students in the master health promotion. And the students indicated that they were discouraged to add things such as, for example, a DAG, because their supervisor thought it was a weird thing to do or did not see any relevance in doing that. Then for opportunity, we first have physical opportunity. So the lecturers also indicated that these introductory courses often have a limited number of contact hours. So as a result, the so-called foundational topics, such as understanding p-values, are prioritized. And also introducing causal reasoning in one course may require adjustment in others. But lecturers often lack influence over the broader curriculum or over the content of someone else's course. And as a result, we see a lack of integration of causal inference methods across the curriculum, which might confuse students because they might hear different information depending on the course that they are attending. And then, it's of course, it's a well-known argument, but it was also raised. It's that these courses are often given by professors and postdocs who also need to balance research, teaching, supervision, and administration. So they also indicate that there's often limited time to thoroughly revise the course. Then we have social opportunity, and an often point raised was that there's also a lack of support from peers. And to really introduce causal inference methods in a course. And this could be due to a lack of awareness. There are many colleagues who are just not, don't really know about the existence even of formal causal reasoning. And sometimes it's also, it stems from a resistance to change. Because as an applied health researcher, learning about formal causal reasoning and causal inference methods often entails that you realize that a lot of what you did in the past was wrong. And sometimes, we also found out during the workshops that we gave, is that it could lead to frustration and even a resistance to change. And then, another point why we sometimes see a resistance is because when we submit our research to applied journals, they often do not require that you, for example, state an estimate, or even if you would apply these causal inference methods, you sometimes get questions about it because reviewers are not familiar with it. So it might make it even more difficult. And then for students, it was raised that sometimes there's also a lack of interest from students, and that it's difficult to tailor the teaching approach because in some master programs, students really have a varying academic background. So you can have students with a very strong methodological background, while for other students, this is certainly not the case. When we then move to motivation, so based on these barriers, we see that for reflective motivation, that there's just a lack of self-efficacy to really adapt the course and integrate formal causal reasoning. And then for automatic motivation, they also indicated that the teachers are often entrenched in a certain teaching routine. So considering this habit and the fact that, and all these barriers that I just raised, the path of least resistance is often just to keep the course from last year with limited adaptations. Okay, so now we heard all the bad things. Let's now think about the intervention functions and strategies to adapt this behavior. So first ones, we have education, persuasion, and training. So education is about increasing knowledge. Persuasion is using communication to stimulate action. And then we have training, which is focuses on imparting skills. So we have workshops, introductory papers, and courses, knowledge clips targeting applied researchers. They can all really help to raise the understanding of and experience with formal causal reasoning. And this also improves researchers and hence lecturers' self-efficacy. Furthermore, as the knowledge becomes more mainstream, lecturers receive less resistance to change among peers, so to really integrate it in their courses. So I think this is still really relevant to do. And I would like to show you here a slide of Julia Rohrer at this year's version of Eurosim. And she was talking about these tutorials and explainers. And I think she has it's really nice to hear the recommendation about novelty. So these tutorials, they don't really need to present something novel. It's already very important that it is presented to applied researchers because this information is still quite novel to them. And just seeing these causal inference methods applied within our own domain makes it much more relevant and makes us help see the value of it. And I also think it's an important recommendation regarding finding a suitable outlet because you really want to publish these tutorials and explainers in a journal that actually is targeting your applied audience, and also that the applied audience considers that journal as trustworthy and respectable. So, for example, we wrote 2 introductory papers, and we also published them in journals focused on that research domain. And also before submitting the paper, we contacted the editorial boards, asking them if they would be interested in a piece introducing causal inference methods to their readership. And this really helped us to tailor the content to the specific audience and to really make the concrete examples very specific for that group and understandable. Then the next intervention functions are modeling and enablement. So modeling is providing an example for people to aspire to or imitate, and enablement is increasing the means or reducing barriers to increase capability or opportunity. For modeling and enablement, we really believe that it's important to increase the collaboration between experts in causal inference and applied researchers. And we mean this for research. Like, for example, this is a paper, well, it's a preprint now, but we're examining the role of physical activity and dietary behavior in the effect of family affluence on well-being. And we do it using an interventional effects approach. And by doing that, by collaborating, Maxime and I, we really learned a lot about using interventional effects. But on the other hand, we could also really provide our domain knowledge on this topic. And I think it's just really relevant for applied researchers to get more knowledge on formal causal reasoning and to also get some experience with using causal inference methods. And again, by publishing this paper in a journal that is relevant for our field, we increase the awareness about the importance of causal reasoning, which again makes sure that we have a reduction in resistance to change among peers, because we can refer them to this type of papers. But we also think that is really relevant for creating course materials. So working together with experts ensures that the methodological content is accurate, while incorporating the domain-specific examples really helps to maintain the student engagement. And for instance, we're currently considering to apply for funding through an educational innovation fund. And this would allow us to create really nice materials, like, for example, learning paths and knowledge clips, explaining these, explaining more about causal inference methods, maybe even in Dutch, to students. And then we have environmental restructuring. So environmental restructuring is simply just changing the environment to make the required behavior more likely. I think you all know that it's like putting a fruit basket inside, but of course here it will be something else. Here we think that based on the discussions, we found that creating like a new working group on research methods, which supports the consistent integration of causal reasoning across the curriculum would be really interesting. But by doing so, we would of course improve the integration, but also by spreading the content over several courses, might be more feasible considering the limited number of contact hours that these introductory courses often have, and also to have the time to adapt the course. So that's not one person who needs to incorporate everything. But also from a research perspective, we have, for example, Annick, who recently co-launched a special interest group for the European Health Psychology Society. This SIG is really focused on one of the aims is to introduce causal inference to help psychologists. And they also created a podcast, Define and Conquer, where they will focus on causal inference within this specific domain. And it just creates a context, a platform in which people can learn about the value of causal inference, but within their own domains, and to talk with like-minded peers. And then we have incentivization, which is the use of rewards or reinforcements. And there we believe, but this is of course on a broader level, but we believe that incentives in academia should be revised to stimulate good research practices, which includes shifting towards slow and open science, and also this emphasis on research quality instead of quantity. Like for example, here at like just one way to do so, but here at Ghent University, you needed to have a number of publications before we could defend your PhD, and this is now changed. So, for example, for the Faculty of Psychology, you don't need to have a publication anymore. While before, some groups even informally requested 5 publications. So it's more shifting towards quality. And also, I think providing incentives for example, pre-registering a study protocol would really help with it. It would help us to tackle the lack of support from peers by raising awareness.
Yes, so then we go to the policy categories. So remember, the policy categories are the gray area in the circle. So they can only influence behavior indirectly via actually facilitating the intervention functions that Louise just presented. So the first one that we included based on the discussion that we had during the expert meeting is regulation. So this is the use of rules, policies, or formal standards to influence behavior by mandating, restricting, or guiding actions within a system or a context. And so one important role we saw there was for journal editors of applied journals to actually raise the standards of peer review, giving clear guidance to peer reviewers, for example, that there should be clearly formulated research question, that it should be made explicit whether it's a causal question or a predictive question, and that if it's a causal question, that they also should use the appropriate analysis for that. So that this is something that peer reviewers should watch out for. Another thing that they could do is require pre-registration, which would also require, of course, thinking clearly about your research question and your analysis beforehand. And so these measures could decrease resistance of researchers and increase their self-efficacy to precisely formulate research questions and construct causal models before going to study design and analysis. Then another thing is more at the level of universities, is that causal inference could be taken as a key learning outcome of bachelor's and master's programs. And this actually could not only be relevant at the level of the university, but we discussed that it could even be relevant at the level of high schools. It could be included in the curriculum there. Jelle Van Cauwenberg had a master thesis student who actually tried this out. So she taught about causal inference at a high school, and she had very positive experiences about that. So it seems to be feasible to teach this in high school, and that would already make the students there aware that causal inference and causal thinking, at least, is important, and that would then facilitate learning about this in bachelor and master's levels. And so, of course, this would facilitate the integration of causal inference throughout the curriculum. Then we have guidelines, so creating documents that recommend or mandate practice. On the level of guidelines, we thought about reporting guidelines for observational studies aiming to answer causal questions. So we have, of course, the stroke reporting guidelines for observational studies. And there are some of the factors that link to causal inference, but they are not very explicitly in there. So we might consider making that more explicit so that people are really aware that this is something that they should think about. Or, of course, we could create separate guidelines, reporting guidelines. And one example is reporting guidelines for target trial elimination that already exists. So you can see it on the slide. It's the target statements. And so this could raise awareness and disseminate knowledge amongst colleagues and societies about the existence of causal inference methods and how they are relevant for research and through research then also education, because if it's relevant for research, then we will see why it's important to also teach students about this. And then the last one is service provision. So this is about the delivery of resources, infrastructure, or support services that enable or facilitate behavior change. Their universities or faculties should allocate dedicated funding for statistical consultancy in both research and education. And I think, at least in Ghent University, there are already very valuable initiatives such as Flames and the Cell Biostatistics that provide consultancy for researchers. But there are many researchers who could benefit from getting statistical consultancy. And actually, if all researchers would start to make use of these services, then they would be heavily over-demanded, over-asked. In guidelines of UK for reproducibility and research integrity, it was actually stated that ideally in every research team, there should be a statistical expert. So if we want that, then I think we have still a way to go and that there is need for some more funding on that level. And that would, of course, help us with the lack of time to adapt courses and the lack of understanding the importance of causal thinking. And I think especially also the lack of knowledge, because then there would be a dedicated person in every research group that could help us with all of these things. So I think we have presented now a lot of barriers, some solutions. And of course, we know that changing behavior is complex and it's difficult. It requires time. It's almost like trying to turn a very heavy container ship. We have tried to start pushing against the ship, but we know that the ship turns very, very slowly, and we could use additional hands to help the ship turning. While we presented solutions at different levels, of course, at the policy level, this is more difficult for us to change directly. But I think there is also some low-hanging fruits. There are some things that we could try to incorporate immediately. And some of the things that we were thinking about is referring applied researchers through these introductory courses, creating working groups focused on causal inference within your domain of applied research. For example, special interest groups, as the one that we have founded at European Health Psychology Society. As a reviewer, introduce authors to causal inference literature when you feel that they have a causal question and they have not appropriately addressed it. Share your course materials. We can learn from each other, reuse things so that we can improve our materials and that we feel enabled to teach about causal inference. and not only integrate causal reasoning inside the very advanced statistical courses, but also outside statistical and methodological courses. So these are just a few of the things that we thought about, but we are very curious to hear some of your ideas as well. So if you have ideas, please feel free to share them with us. So this was it for our presentation. So I hope you enjoyed it, and we are open for questions.